Okay, so I have very few slides in this presentation because we want to do more hands-on. Okay, so if you remember, we actually started our Wireshark journey with how to capture different files, how to capture from different files, how to merge, how to mark packets, so many things we did. Then we moved on to profiles and time-based calculations in Wireshark, how it happens, how Wireshark captures packets, all the logic behind the Wireshark engine, and then we went to capture filters, and then we went to display filters. So this time we will be actually doing on statistics, the statistical features which are available in Wireshark. And we'll do something called as capture file properties. We'll touch upon endpoints and conversations. We'll use the Wireshark as a rich set of graphs which we can use. One of the most widely used graph is IO graph, input-output graph. We'll show how to generate it and how to use it. Something called as flow graph is also there. We'll show that. Then there is IP version 4 statistics and something called as packet length and other items, small items which are there. Okay. And we'll do a lot of demos. Okay. So this is the only slide. I'll not be using slides because the most of the thing we'll be doing in Wireshark. Okay. So I have certain files open. So let me open the first file. Okay. Can you see the file, Bhagat?
Yes, Anand.
Okay. Thank you very much. So let's start with we have a lot of options. So all the statistics related options are actually in under the statistics menu. Okay, if I click here, there are so many things. Like first, let's test the capture file properties. Before that, say imagine you are an analyst, okay, a security analyst. Means you have got a file, and the person who actually created that file has sent it to you. So first thing you mostly like to do is just check the file. Okay, just click on capture file properties. Okay, and you can see like what is the name of the file. It becomes very important because if an analyst is sending this to another analyst or to group of analysts where they want to analyze this, you have to name it properly. Okay, what is the length matters because is it a big packet capture or is it a small packet capture? Hash is very important because if the file is corrupted, then there's no point in checking it. So hash is very important. So format is like what, because we have new Wireshark format called as, we'll just see now in 2 minutes, PCAP NG. So whether it's a PCAP or a PCAP NG, that also matters. And the snapshot length and other things. And when the packet was captured, the first packet and the last cap, this is a very fast packet capture. That's why the time shows as 0. So means it's not that it was captured without any time lapse. It is there, but it's in nanoseconds or microseconds. And sometimes this also matters whether which hardware, which OS, but sometimes Wireshark cannot capture it. So it shows like the hardware and OS application. Okay. And here at the last, it shows how many packets were captured, average packet size, and other things. Okay. And how many packets are displayed if there was a display filter and then you save this file and send it. So what I will do is I'll close this and I will show you another file. Let me close this and bring this one. This is a very big file relative to the previous one. And if I click on statistics and if I click on capture file properties, you will see that this is a 6 MB file. Okay? And all these files are captured from Wireshark wiki. So nothing has been created by me. So that just to show that there are a lot of things you can play around with Wireshark wiki. And you can see this is a 6 minutes almost packet capture. And there is 13,804 packets captured. The time span, the average packets per second, is the packet size, average, the bytes. Now imagine that you have to send it to another person, saying that, like let us imagine this scenario. You have got this, you captured this, and you want to say you are a say cybersecurity analyst, and you want to send it to your superior or manager, and you want to give some comments. Okay, you can send it via email, but it is better you actually put some comments. So here what we'll do is we'll put some comments. We'll say this is a very important file. There is something wrong in SNMP or whatever it is. Okay. Okay, please check packets 3 to 4. Okay, something like this. And what will happen is you will save these comments. Okay, so these comments are saved. Now I'll close this. You can also copy to clipboard. Okay, and if you open Word, or whichever application you have, you can paste this. Okay, so that is copy to clipboard feature. But good morning, sir. The copy to clipboard feature. So let me close Word, and then if I come here and if I close this file, okay. Now, right now, if I again open the capture file properties, the comment is there. But if I try to save this, okay, and I will say something, say SNMP, okay, and if I try to save it, see the default type here is PCAP, okay. So, and if I try to save it, it says the capture as comments, but the file format you chose does not support comments. Means PCAP NG is the file format which actually supports comments. PCAP does not support it. So, you can discard the comments, but I want the comments. So what I will do is I will say no, and as soon as I say no there, it changes the format to PCAP NG, and I will save it. Okay. Now I will close this Wireshark packet capture, and I will actually open SNMP. If I open SNMP and if I go to statistics and if I say capture file properties, you can see there is the file format. Okay. Now, if you remember in the first session, or if you have not watched this, please watch the first session from the archives. Is we can mark packets. Okay. So I can I can go here and say mark packet and mark 3 and 4. Now when I do this, and if I go to statistics and capture file properties, and if I scroll down, you can see 2 packets are marked. Okay, and time span and all the other things it will calculate, and you can mark the packets, and I also check packets 3 to 4. Okay, now I'll save it and close it. This is the capture file properties. Okay, and we are adding comments in this. Don't get confused with packet comments, or what I'm trying to say is you can actually add a comment onto a particular packet. So I can right click here and I can say packet comment. Okay, so I can say please watch this. So this is different from the capture file comments. Okay, and I can also add one more here. Watch this. And if it is a long file like this, we have some 13,804 packets. What you can do is you can right click on the packets and you can say apply as a column. Okay, so you can see if whatever is tick here, it means that it has a comment. Okay, don't get confused. This is different, and packet the capture file properties comments are different. That you are giving comment for the entire file. Here you are actually giving comment on each packet. Okay, hope that is clear. I just remove this column, and that's about the capture file properties. There is something called as resolved address. It's like what ports are being resolved. Okay, these are all the TCP/IP ports in IANA, Internet Naming Authority. They have this file, and what we'll do is we'll not go into the resolved address. We will cover DNS in a separate session. DNS is a very, very important topic, and we can learn a lot from Wireshark. So this is just to show, just for the completion purpose, like what resolved address means actually. Okay, so you can actually enable the host and the services. We'll see the host resolution in the next part. Okay, in the next capture. Now let me close this and let me come back to the capture one. And if I come to statistics, okay, and let me come to endpoints. Okay, before coming to endpoints, you can see there is a lot of packet captures. I think there are some. Okay, this is a very small packet capture. This is only 10 packets. Okay, so we'll come to another one very quickly. If I click on endpoints, so there are two. If I go to Ethernet, okay, what is endpoints is, what are the end stations which this Wireshark packet capture has? Like, what are the end hosts or routers interfaces or switch interface if you are capturing that? So it is giving you the endpoints, okay, A to B or A to C, whatever it is. The endpoints, the end stations. In the end stations, it can also happen that like you might be having two Ethernet cards on a system, and it will say two stations, means two Ethernet addresses. Means what I'm trying to say is, if you have station A with two Ethernet cards and another station B which is there with one Ethernet card, it will show as 3 if you're capturing on both the interfaces. So if the packet comes from goes to B and comes to A with other on the other interface. So be aware about that particular thing, but right now it's very simplified. Don't worry about the complications. So we have two stations here. One is the Ethernet address and one is the two Ethernet addresses here. And if I click on name resolution, it shows like from where it is, like the first 3 parts. It's the Apple thing and there's a Kingston. Okay. So which addresses are there? Okay. Then how many packets were captured? And if I come here in the end station, it says 10 packets were captured and 1523 bytes were captured. Okay, and it transmitted 5 packets, received 5 packets, and the bytes you can see as 740 at the end. So this is the Wireshark problem. It shows the received bytes at the end. Okay, so it's like it transmitted 783 bytes and it received 740 bytes. Most important thing is, one thing you have to understand is the packets here and the bytes are different. Means what I mean to say different is, don't assume that a station which sends highest number of packets is sending a lot of traffic. It might not be true. So a station might send 2 packets but with maximum byte size. So bytes is very important rather than number of packets. Packet becomes important when a station is sending a lot of packets with a small byte size. Okay, we'll see that very soon. That is the most important thing. And then here it's not, here it's okay that these two stations are communicating, but in the next packet capture we'll see that there might be more than one station. So transmit means what this station is sending, receive means it might be receiving from many stations, not one station. But in this case, since there are only 2, both are communicating with each other. In IP version 2, from these stations, it says like what are the IP addresses associated with this 2 stations. Means it can be like the IP address. Here it is IP version 6, but in this case it's only IP version 4. The same logic. How many packets were sent? How many packets? How many bytes? How many packets were transmitted? How many packets were received? What are the byte size? And this there is a plugin you can associate with Wireshark. It shows from based on the IP address. It can show from which country, from which city, where if it is a public IP, what is the autonomous number, the BGP domain, from where it comes from, an autonomous system organization, which owns that AS number. But that is, we have not added it, so don't worry about that. And from this each station, what are the TCP packets? So actually what is happening is 69.2 is communicating with 69.1. That means with on HTTP. So there's a web communication which is happening between these two. So you can see 80 there. And the same logic. Okay. And if there were any UDP packets, it would have shown here. Now, I'll come back to this thing very soon. And also you can add, it's not that only these are available on these endpoints, we can add many endpoints. We can add, say, if you have, you can add IPX, okay? And if you are using IPX still, so let me remove it. You can add fiber channel, FIDI, Bluetooth. If you are using wireless, you can add those things. So I'm not adding. So it's not only this, you can customize here. You can also copy as a CSV file and as a YAML file. So if I copy a CSV file and I open Excel, and if I paste it here, so it gives me the access. So it gives me this file, and Excel wizards can come and do a lot of things here. Okay, and if YAML, if you know, YAML is mostly is used in network automation, in Ansible, in Kubernetes, and everything. It's a very it's like a data format. So this is your YAML file. Okay. Now, related to this, this is showing the communication between 2 points, endpoints. Okay. Now, if I go to statistics and if I click on, say, conversations, it shows the conversations which is happening. So here it's only one. Okay, so it says only one conversation is happening between these two endpoints, and as we suggested, like it's there's a web communication which is happening, and we can actually see like how many bytes were transferred, how many bytes were sent to packet A to B. The same thing, because there is only one conversation, and here you can. This is giving a relative stat. I'll come back to this in the next packet capture where we have multiple communications. Okay, so we can also do like this. We can also right click and say apply as a filter and say selected, and we can select whatever we want, A to B, both communications, A to B only, or B to A, or if there are multiple communications, A to any, A to the two-way communication between A to any, one-way, and the reverse. So all probabilities or permutation and combinations are possible here. Okay, and you can apply as a filter. Okay, you can prepare a filter. You can find this communication, and you can colorize. Say for example, we can colorize only, let's say, B to A. Okay, and you can put a new rule here, and you can say, for example, B to A or A to B, whatever it is. Communication, commute testing, something. Okay, and we'll say okay, and if I close this, you can see it's like the particular thing is communicated. We can also change the color. So if I go to capture file property, if I go to conversations, and we can say colorize up this, say A to B, and we can say foreground is something this, background is let's say okay, and background is something, say, I don't know what color we have. Let us choose a background. Okay, and say okay, choose this. Okay, it came. Let us change a different background be orange. Okay, and foreground, let it be okay. And if I say okay, and if I say close, you can see like this. Okay, so this is we can colorize the thing, and you can add the capture file, mark this packet, and send it to the other person. Now, this was a very easy one. Let's go to this one. Okay, and if I come here, and if I come to statistics, and let us go to endpoints. So there are more than, as I said, there are more than 2 stations. There are 3 stations here. Now in these 3 stations, the packets are 483, and the second station sends 141 packets, and the other station sends 342 packets. The byte size, if you see, is different. So even though this station, the second station is sending 141, it's only sending 54K bytes. So it always remember that it's not like the logic is if there are more number of packets, the byte size will be more. It's not like that. Okay. And how many packets were captured, how many packets were transmitted, how many packets were received, how many bytes were sent, and how many bytes were received. Okay, so the byte, if you see, it's at the end. So this is a Wireshark problem. Okay, and I can also click on name resolution, so you can see from which company it came from, and I can also do a name resolution. If I go to, let me close this. If I go to edit view, and if I say name resolution, and I can say resolve network addresses, and sometimes it might be a problem, but usually so not conversations. I'll come to conversations later. Statistics, if I go to endpoints, and if I click on name resolution, if these names are there, it will resolve. Okay, it's not that it happens every time. Okay. So it gives one, served by advertising.com. When this is important is for example, you can go to, if you're a security analyst, and if you feel like, okay, there is someone has given you a ticket saying that there is some issue happening, and when you do a name resolution on that packet capture, you feel that, okay, is this domain a good domain or a bad domain? So what you can do is you can go to virus total. Okay, just give me a second. Okay, now if I just, let me maximize this, and if I just type virustotal.com, okay. And what I will do is I can go here and I can search for either IP address or the domain. I can say whether this served .advertising.com. I think that was the thing, right? Let us cross check once again. Served by, okay. Served by, just a second. And if I press enter, it will okay, it says, okay, this is the ad. It's not that it's wrong. Okay, 10 plus detected files communicating with this domain. It says this sends ad. It might also be a domain which is sending malware. Okay, Cisco Umbrella is giving this ranking. It is based somewhere in US. Okay, and they have actually stopped transmitting the owner information. That's okay, and you can further dig into this. And it's not that by sending ad is bad, but if it is malware, then definitely you should go and check with the user and actually do some incident response. Okay, so that's why this becomes very handy. It's not that because some document says don't enable name resolution, it's not good. It's not like that. It depends on scenario to scenario. Okay, now the same thing, but let's see what is this communication all about. Okay, so we have this who is communicating and what is the conversation which is taking a lot of communication. Okay, so in this what I will do is I'll just click the bytes. So this station is sending a lot of bytes, okay? And if I come to IP version 4, I will click on once again bytes, and I know this 10001 is actually sending a lot of bytes and receiving bytes. So so I want to know what is this, okay? So this is about like endpoints. Like I know there's some communication is happening, but I want to know which station this 10.1.1.101 is communicating, and why this is, what is happening in this communication, why it is 319 kilobytes, where and others are relatively less, okay? And we can also go here and we can also do the bytes thing. And again, I think this communication with web server is the one which is taking, but we can do like this, or what we can also do is go to conversations, okay? And if you see in conversations, only two are communicating, that's okay. And here what I said, relative stat. Relative stat is from like it's giving, when you open, it is taking that as 0 and it is showing, calculating the time. We can also have absolute start time, okay, when is what captured. So sometimes this makes sense and sometimes relative time makes sense. So if this is a security feature and you want to know when this has happened, the attacker is actually whether he is attacking in the night or sometime where on the Saturday, Sunday, this makes sense. But if you are just doing some analysis, relative time is fine, okay? Now what we'll do is we'll come to IP version 3. So there are 3 communications. Let us see which one is the, I think it's organized already. So 10.1.1 communicating with 10.1001. This is the one which is taking a lot of packets, okay? And if I come to, there is no IP version 6, there is no UDP. And if I come to TCP, and if I click the bytes, let us get the big bytes. So it is this one, 10.0.0.1 communicating with 10.0.0.1.1. That is our web server, 80. So what you can do here is right click, and I can say apply as a filter, and I can say selected both ways. Okay. Now if I close this, you can see in the filter it's already there. Okay. Now let's see what is this communication. Okay. So let's right click and say follow this TCP stream, and it says give something. Okay, it says there is something image. That's why it's don't think that it's all the communication happening is malware. Nothing like that. We checked. It is just an ad. So, but I'm the curiosity. You want to check why this is taking so much size. Means what is being transferred, and you can say it's a GIF. It's something image. That's fine. And let's do like this. Let's see what image was that. Okay. To do that, go to File, Export Objects, and say in the HTTP what was the objects. Okay. So you can see that there were so many images. Okay. And let's see the size. So this image is sorry about that. So this image is one which is taking a lot of size, 191 kilobytes. Okay. So I will select this and save this, and I will save in my in this file, in this folder. And if I go there, and let's see what is this image. Hope this image is a good one. Okay, it's a very good one. All of you love dolphins, right? So someone was is animal lover or dolphin lover, and he was browsing, and that's why, or he was planning a trip. So here it is. So from the statistics thing, you can see what is happening. One thing I want to highlight here is never do this, okay, unless you are on a sandbox, not on your actual machine. I tested this because some of this might be malware, and don't think that Wireshark is a safe tool. Wireshark is a very good tool, but it depends on what you're capturing and what you're exporting. So if you're a security analyst, and on your station you are exporting a ransomware or executable, and you export it and try to open it, it will lock your computer. Okay, so be very careful on what you export. The other tools like network monitor and those which do a better job. What you can also could have done is calculated the MD5 of this file and go to virus total, okay, where you already have, and actually you can put the MD5 here, okay, or hash, and it will say whether it's a good file or a bad file. But if it is a zero-day attack, you never have a hash of that file being uploaded on virus total. Okay. Now, and also one more thing before we close with this endpoint and conversations is, let me remove this and say for you want, let me open another file. Let me open this. Let me see what is this. Okay, this is the SNMP file. Let me open this. I'm just checking for some. Okay, we can, sorry, let me open this IO graph. I want to show you some feature there which is available. So here you can see there is TCP and there are other things. Okay. Now, say for example, you want LDAP only, or LDAP, let us put LDAP. Okay. And you want to see the statistics of which devices are communicating. You can go to endpoints and you can say limit to my display filter. Okay, then it shows which devices are communicating according to the display filter. So if I remove this, and you can see 3382.1947.323 and 1129.7U9, and if I click limit, it will just limit to this. Okay, I can also do this way. I can also do statistics, go to conversations, and I can also limit to the display filter. Okay, and say 777. So it's based on, you can limit to a display filter, and you can set a display filter here also, right? Right click, apply as a filter, and do it. Okay. And one last thing before we actually do this thing, let me close this. Let me open the Syn Flood Sample. So this is actually a capture of Syn Flood which is happening. So if I go to statistics and if I go to endpoints, you can see here they are sending only one packet, but they are not receiving anything in the TCP. If I go to Ethernet, there are two stations. Okay, so this station is receiving 40 and the other station is sending 40. And if I click on name resolution, one is Cisco. Most probably this is the router and this is the station which is launching Syn attack. Okay. And if I come to IP version 4, you can see these are the IP addresses, spoofed IP addresses, which are being created here. And then if you see here, all are trying to send this to 192.168.0.1. Okay, you can see 40, and it's actually it's not sending anything, it's receiving. And if I go to TCP, same thing. And if I go to statistics and if I go to conversations, you will see better picture. See here, all are trying to attack 80 with different Syn attacks with different IP addresses, trying to overflow that particular address 192.168, this thing. So this router, and these are all the TCP 40 communication. So like this you can identify, because see the packets, it's one, it should be more than, usually it will be like a lot of packets as you saw, and a lot of bytes, but here you can see A2P is 0, but B2A is 40 something. Okay, so in the Ethernet thing, and if I say name resolution, you can see, yeah. Okay, now let's go to the graph thing now. Okay, now this is a big packet. It has around 7A6836 packets. Okay, now there's a very good graph in statistics. It's called as IO graph. If I click here, just give it some time. So it shows here all packets. Okay, these are all packets. TCP, UDP, whatever packets. Okay, And these are the TCP errors. Okay, and here it's the color, the style of the packets. What is the y-axis? Y-axis and y field are the same. Means it's like here if you have white field, you can apply calculations. I'll show you that in a moment. And smoothing moving average. So this we don't use it. And also you have a drag. So what does drag means? I can drag this, okay, wherever I want. And a zoom means, as you know, zoom. So it zooms. So if I want to reset, like what we do in Google Maps, there's a reset button. It will get back to the original thing. And time of the day, if you want the time of the day thing, if you're capturing, you can remove this, again reset, and you can have a logarithmic scale. And interval can be 1 second, 10 seconds, 1 minute, 10 minutes. It depends on your packet capture. Sorry about that. Okay. We can also, let me do one thing. Let me remove this. We don't want this graph. Okay. And what we'll do is I want TCP and non-TCP packets. Okay. So I will say this is TCP versus non-TCP. I want to see how many TCP packets are there and how many non-TCP packets are there. Okay, and I will say what I can do is this same thing. This is non-TCP, and let's give this TCP. Nothing is coming. I'll tell you why, because you're not clicked on enable. Display filter, I will say only TCP, and this non-TCP, I will say this as nothing, means not TCP, nothing. Okay. Colors, let's click here, and let's do this. Say okay, and this, let us do this. Okay. Okay. And let us do this as a bar, and let us do this as a line. Let's see how it appears. We can change this. Let us do this bytes instead of, see here, this, when you say the y field, when you do some calculation, the y field comes into y field, the other thing comes into picture. Otherwise we can select bytes. Okay. So and very important, you have to remember the scale. Don't do one for bytes and another for packets. That doesn't make sense. Okay, as we saw, packets can be more, byte size can be less. Packets can be few, byte size might be very high. So always have one parameter. So select this as bytes. Okay. And let us say select this, enable. Okay. So you can see like it's happening, like the line size is coming here, and we can drag this, reset, mouse drag, come here. Okay. So you can see this during this time. We can also change this line. Instead of line, let's go here and say bar. Okay, and give it some time so you can see the bar. We can also change this to stacked bar. Okay, nothing much difference. So we can play around with this. We can also say in the IP how much is TCP or how much is other things. Okay, so this is very important graph, and then you see the bytes size here and the time. So we can also spread this. Let's say we use 100 ms seconds. See here, it's almost the same. Okay, 100 milliseconds. We can also increase it by 10 seconds, and you can see a better graph. Okay. And also if you move, so it depends on your situation, how you manage this. Okay, it's not only thing. If you click here, there is a display filter. You can play around with, you know, the power of display filter. You can play around with that. So this is the IO graph thing. Okay, and there is, okay, if I come to IO graph once again, I want to show you one thing here. Okay, now it spread. It took the default. Now, if you can see here, if I copy this, I can copy this, and let me see what happens if I copy and paste it in the Word, not in Outlook, sorry. If I come here and if I say Word or whatever it is, let Word open, and if I try to, I've copied it, and if I try to paste, you will get the thing, coordinates. But I don't want this. I don't want the coordinates. I want to, if I click on Save As, okay, you can see here, I can save as PDF, I can save as an image, I can save as a JPEG image. So what I will do is, let me see, I'll save as PDF, and I'll say save this. And if I go to the folder which I'm working on, this document appears. If I click this, so here is the graph, okay. And if you save it as an image, you can put it in the report, in the PowerPoint, or in the Word document. If I save this, and if I go to this, that is this image. So you can this Windows thing. Okay, so you can actually open this and show this. Okay, so this is the image, and you can cut, copy, paste that image. Coming back, so that was about the, and you can also have this very good display filter. Okay, and here you can see copy from, this is disabled. You can copy, like if you have two profiles, if you remember we had multiple profiles in Wireshark 2. If you have two profiles, you can copy this from another profile out to another profile. Okay, very good. Now there's one more graph called as flow graph. If I open this, okay, what flow graph does is it shows the flow in a graphical format. So if I go to statistics, and if I click on flow graph, it looks, I'll tell you how to decipher this. It's saying that what are the communications which are happening, what are the stations involved here, and what are the communications happening. Okay, so it's very difficult to actually, you can see flows. Okay, you can select TCP flows, ICMP flows. Let's select only TCP flows. Okay, and you can see here sequence 0, sequence ACK 1, and everything. If you are better, select all flows. And to see this in a better way, I'll save this as a PDF. I'll say FD or flow graph FG. Okay, and just wait for the document to be saved. FG is saved. So if I click here, and it's a better thing now. If I zoom this, okay, you can make out what is happening. And if I scroll here, you can see like SYN, ACK is happening here. Okay, and then a get happens, so it's showing to where it is going. So it's going to this page, and then if I come to this packet which says it is it's contacting some station outside its local network, that is 292.25.11. So it's like something another SYN means it's coming. So you can, and also you can see the HTTP post here which is happening. So this is very good thing. Means if you want to really see what communications is happening between stations, how is the flow, because if you're a graphical person, you can see this. Let's go here and let's open the Syn Flood sample which we saw. And if I go here, and if I say statistics, and if I say flow graph, you can see here, see how many stations are involved. And see, only SYN is being sent here, only SYN. So this is one more way of easily identifying a SYN attack, okay, or Syn Flood attack. Okay, then there is service response time. We are not going to do this because we need some certain protocols here. And what service response time does is it shows like, let's not open this. Let's open the IO graph or something, the packet capture, because Syn Flood there's nothing there apart from the SYN packets. So if I go to statistics, service response time, it shows what is the service response time. if you log into radius or if you log into diameter. When this is important is if you're having a wireless or LDAP, or if you have to authenticate with an Active Directory, and if the response time is very low, you can click here, select that, and see is it happening or why it is happening, what is the problem. So here the service response time graph will come. Okay, there's some more things, small things we'll finish off quickly. IP version 4 statistics. I can click on destination and ports. This shows what all destination and ports this station 192.6.0.1 is communicating. So it shows the rate, and let us wait because there's so much communication. It shows like 2069 packets. Out of that, 58 point overall is 100%, and it's like 58 from here. Out of that, TCP was 94. Out of that to this 389 was this much. So it's showing what all communication is happening. Okay, destination ports, and it is showing the percentage burst rate. You can set it. We'll do. It's a mathematical thing. We'll dedicate some time later. So let's go. Let's close this. Let's open a simple one. It will make sense for you. Let's go to our capture file and let's open the HTTP one. Or let's do this. Let's do something which we understand. OSPF. Okay. And if I go to statistics and if I go to IP version 4 statistics, destination and ports, you can see here what are the stations which are there. Okay. And what are the destinations, and what is the rate. And let me close this. We'll open the better one, statistics, IP version 4 statistics, source and destination address. Okay, so if you see here, this is the source and destination, 2 stations, and this is like DR-PDR communication is happening, and these are the things. So you can see what are the IP version 4 packets, addresses, the packets, what are the source IP addresses, and you can see the rate and the percentage. Okay. And if I come here and if I say statistics and if I go to IP version 4, I can also see the protocol types. So here it says none. And if I go open this IO graph 1 and if I go to statistics, I think it will be more than 1. Another 5 minutes extra, I'll finish this off. If I say IP protocol types, you can see STP is there, UDP is there, and other things. IP version 6 statistics is okay because we don't have any IP version 6 packet capture. And very important 2 things. One is protocol hierarchy. So this shows like what are the protocols in your packet capture. If you see this, you have a lot of protocols. You have Ethernet protocol. There's a malform packet. You can select apply as a filter and see that particular packet if you want. There is IP version 4. There is a VRRP. There is connectionless LDAP, and there is so many things here. Why this is important from the security point of view is you can see whether some undesired protocols are there. If someone is using a mute-orand or someone is using Dropbox, or someone is using protocols which he or she is not supposed to use in enterprise network, you can identify it. So this is a very, very critical, and how many of them are there? And also from the performance point of view, if you're seeing a lot of packets, if you want to see a lot of packets but they are very less, then also it's an issue. And if you're seeing more packets than you're supposed to see, if you have a baseline and if you compare, that's also an issue. So please, this is a very, very important. Let's go to a simple packet capture, and that also makes sense. Let's go to capture 4, and if I go to statistics, protocol hierarchy, and here you can see the JPEG, the hypertext contains a JPEG. If it contains, say, Windows executable or something, a JavaScript, it's not wrong, but as a security point of view, it gives means avenues to explore. Okay. During incident response. And one more thing related is this packet length. So usually your packet length will be less than 1514 because of the Ethernet thing. But if you see more than that, means there are jumbo frames, If there are few in this range, 20 to 39 means there is some problem. Usually packets will be from in this range. Okay, it should not be in this range. So I can also see, but here I can't display. So here you can see 42 to 57. You have to select the packet length and see why it is. What are these packets? When this makes sense is if I go to Syn attack, I'll understand. So if I go to Syn Flood Sample, and if I go to statistics, and if I go to packet length, see here, there is no other packet, only in this range. So means there's something wrong. Okay, another way to identify an attack. And let me open, just give me 2-3 minutes, we'll wind it up. You can open the, I'll open the, sorry, I have the thing. I will open the polling, give me 2-3 minutes. If I go to DHCP, okay, we'll explore DHCP in great detail in future sessions. If I go to statistics, and if you see DHCP boot statistics, it shows like what is the DHCP discover, how many packets are there, how many packets were offered, how many packets were requested, and how many packets were actually acknowledged. Okay, if there are so many packets and if someone is complaining about DHCP problem, you can select the packet capture, and instead of filtering, you can go here and it will give a better picture. Okay, and the same thing with DNS. If I go to DNS, and if I click this, and if I go to statistics, and if I go to DNS, you can see it can show a lot of details on DNS. What was the query response? What were the different query types, which makes real sense? And what was the service stats? What is all DNS? We have to do not 1-2 sessions on DNS, because DNS is a very complicated topic and very interesting topic. Okay. And we have, that's the packet capture, but I want to highlight because there are so many things here. The TCP stream graphs, multiple, HTTP, HTTP2, we'll have a session on it when we cover this thing. There are some other things here. This is Open Network Controller. If you are running that, you can have statistics. 29 West is low latency messaging from Informatica. If you have that, you can do statistics on that. Access node control protocol, that is for DSL, digital subscriber line. You can if you have that, you can test it. BACnet is for building network protocol, that you can actually test it. Collect D is like Nagios or the monitoring system from Unix. We can test this. Halt IP is like sending digital signals by analog lines. Now they are using IP. If you have that, we can test it. These are all there. I'm just explaining. HP feeds is not from HP. It is HoneyNet protocol. So we can test that. Same time is like IBM communication protocol. So if you have that, we can use this. F5, is like the famous load balancer. If you have that, we can see how the statistics is happening. Means if there are 5 load balancers, how the packets are going to each load balancer. It shows that communication. Okay, if you have that packet capture. So that's all about statistics. And what I will do right now is I'll stop sharing it. Bhagat, can you stop the recording? I'll open the poll.
Okay, Anand. I'll stop
please, yes. Let me add the poll 1 second.